When computer networks were being developed, it was discovered that each different manufacturer was developing their own standards. So, for example, if you had a HP device, then it would be able to connect to and communicate with another HP device or HP printer, but it wouldn't be able to connect to or communicate with an Apple device. So in the 70s and 80s, two conceptual framework for understanding and designing computer networks were developed. First was the TCP IP model that has 4 layers developed by the Advanced Research Projects Agency, ARPA. And then this was improved upon with the OSI model with 7 layers that was developed in the 1980s by the International Organization for Standardization, ISO. Now, in truth, both models were created to standardize computer and network designs, and whilst the OSI model has more layers, it is often used as a theoretical framework for understanding network protocols and architecture, while the TCP IP model is more commonly used in practice for the actual implementation of network protocols. So let's take a look at the two frameworks and see how they stack up against each other and why and where they are used. First, we start with the OSI model. 1. Physical layer. This layer is responsible for transmitting raw bits, the ones and zeros, over a physical medium, such as a Cat5 and Cat6 cables, fiber optic cable, or radio waves. It defines the physical characteristics of the transmission medium and the signaling techniques used to transmit data. 2. Then we have the data link layer, which is responsible for encapsulates data from the layer above it, the network layer, into frames that can be sent across the physical network. It does this by using the device's MAC address and a number of protocols like flow control, where the data link layer will ensure that it manages the rate of data sent between two devices so that the receiving node is not overwhelmed by data, and error control, which means that data is transmitted without errors using checksums, cyclic redundancy checks, CRC, and retransmission of frames that are not received correctly. If you are enjoying the free content, please make sure to like and subscribe. 87% of viewers are not subscribed, and just a single for you, but it makes a huge difference to our channel. Now, back to the video. Ethernet runs at both Layer 1 and Layer 2 of the OSI model, and these two layers correspond to the network interface layer of the TCP IP model. ISIS and CDP are also two protocols that are considered to run at Layer 2 of the OSI model. 3. The third layer of the OSI, Open Systems Interconnection, model is the network layer, which is responsible for routing data packets between networks using a logical addressing structure known as IP addresses. The network layer is also responsible for fragmentation, which is when data packets are too large to be transmitted across a network in a single piece, so they are broken up, sent across the network, and the receiving device then reassembles the fragments back into the original packet. This is also called the network layer in the TCP IP model and incorporates protocols such as ping, ICMP, IP, and ARP. 4. The transport layer is the fourth layer of the OSI model, responsible for ensuring the reliable and orderly transmission of data between two devices. Its primary function is to establish a reliable, end-to-end connection between the sending and receiving devices and to ensure that the data is delivered correctly and completely. This is the layer where TCP and UDP sit. TCP provides reliable, connection-oriented communication using a three-way handshake, windowing and error detection and retransmissions, making it slower than UDP, which provides fast, connectionless communication. However, this is without the guarantee of reliable delivery. The transport layer has the same name in the TCP IP model, and traditionally this is where a network engineer stops with regards to provisioning or troubleshooting a network. Unless they are a security engineer dealing with next-gen firewalls, then they can go all the way up to the application layer. 5. Session layer. This layer manages the communication sessions between two end systems. It sets up, maintains, and terminates sessions. 6. Presentation layer. This layer is responsible for data translation, encryption, and compression. It prepares data for application layer consumption. 7. Application layer. This layer provides services to end-user applications. It is the layer that the user interacts with directly. All three of these layers are called the application layer in the TCP IP model. TCP, Transmission Control Protocol, and UDP, User Datagram Protocol, are two different protocols used for data transmission over a network. First up, let's cover TCP. TCP stands for Transmission Control Protocol and provides reliable, ordered, and error-checked delivery of data segments. What does this mean? Let's take a look at our topology. Host A wants to communicate with server using TCP. TCP uses a three-way handshake to establish and tear down connections. TCP also uses retransmission of lost or corrupted segments to ensure reliable data delivery. TCP also guarantees that data is delivered in the same order in which it was sent. All of this means that TCP is slower than UDP due to maintaining connections and error checking. UDP stands for User Datagram Protocol. Unlike TCP, UDP doesn't need to establish a connection to begin sending data and provides fast but unreliable delivery of data segments. Because there is no error checking or connection established, UDP packets are less than half the size of TCP packets. UDP also does not retransmit lost or corrupted packets and doesn't guarantee that data is delivered in the same order in which it was sent. For this reason, UDP is ideal for real-time applications that don't have time to resend data such as video conferencing and online gaming. Now, it's question time. 1. Who developed the OSI model? A. ARPA, the Advanced Research Projects Agency. B. ISO, the International Organization for Standards. C. IANA, Internet Assigned Numbers Authority. D. RIPE, Regional Internet Registry. The answer is B. 2. How many layers are in the OSI model? A. 4, B. 5, C. 6, D. 7. The answer is D. 3. What is layer 3 of both the TCP IP and OSI model called? A. Data link. B. Physical. C. Network interface. D. Network. The answer is D. 4. What type of data is sent across the data link layer? A. Bits. B. Frames. C. Packets. D. Segments. The answer is B. 5. What are the 4 layers of the TCP IP model? A. Network interface, network, transport, application. B. Physical, data link, network, application. C. Physical, network, transport, session. D. Network interface, transport, session, application. The answer is A. 6. Which of the following are characteristics of the TCP protocol? Choose 2. A. Uses a three-way handshake to establish a connection. B. Has a smaller segment size than UDP. C. Is faster than UDP due to maintaining a connection. D. Provides reliable and error-checked delivery of data segments. The answer is A and D. 7. What does TCP stand for? A. Total Control Protocol. B. Transmission, Call and Push. C. Transmission Control Protocol. D. Total Call and Push. The answer is C. 8. Which of the following are characteristics of the UDP protocol? Choose 2. A. Doesn't retransmit lost or corrupted segments. B. Doesn't guarantee data is delivered in the same order it was sent. C. Uses the three-way handshake to establish a connection. D. Is slower than TCP due to not maintaining a connection. The answer is A and B.